Okay, so before the break, we were finishing up the example from the other day and started setting up our computer controlled movements. And it's going to be essentially the same thing that the player controls do, but with a few slight changes. I'll do the overall one after. Well, I'll start with this. I guess I'll start with this. So our update method, where we're doing all these things, that's basically every frame of the game. Every frame of the game that the game engine runs. So like next step, next step, next step, next step. That's happening once in the update method. So on our controls, that's fine, because we're going to sit there and wait. We're going to choose a direction, just keep going that direction. Maybe choose another direction, keep going that direction. And we're putting that decision in. So when we have the computer do it, we'll need some way to indicate that distance. That we don't want to do this every single frame. Right? We don't want to change the direction every frame. That's just going to have our character vibrating around the screen. We want to pick a direction, like when we hold down the D key and move over towards the right. We want the computer to do the same thing, to pick a direction and keep going in that direction. So we'll need some values to keep track of that. And what I think is the easiest way to do that is to just set a timer, basically. And we can access regular time intervals and stuff, but by the nature of a game engine, we have a great way to time things. We have every frame of the game. So what I like to use for timers is just to count the frames. So I'll come up here and set up an integer and call it frame counter. And I'm going to start it really, really big. I'll say 3,000. Because then when we pick a direction, we want to keep going that direction. And we're only going to change periodically. So that's our first thing the computer needs to decide. Is it time to change direction? So obviously there's probably going to be better ways than this, but for a quick getting started one, what I decided would be a nice, easy way to get started is just set that frame counter to some value. So if frame counter is bigger than, say, I have to go dig it up, dig through project settings and stuff. I'm pretty sure the default is 140 frames per second. One of those numbers that makes sense in our minds. But 140 frames a second, so maybe normally when we're not under time constraints like Classroom, you might go over to your game, hit play, and just hit the buttons and see about how long you move in a different direction at a time. Pick a starting point like that. But maybe every 2 seconds, a little over 2 seconds, 2.5 seconds, 333 frames. And if we're going to do that, I'm going to come down to the end. And the very last thing we'll do every single frame is increase that counter. So that after 333 frames have passed, so at 140 frames per second, 140 times 3 is 420. 140 times 2 is 280. So that seems right about between those two. So roughly 2.5 seconds. So every 2.5 seconds, we'll have the computer change direction. Or maybe that's too long, right? Maybe our character will run real far away from the computer before we realize it. So we'll, and every time, how do I do that first? So if we go into this condition, then we want to reset things. We'll make sure that we're not attacking. So this is where we change our mind. So first thing we're going to do is make sure that we're not attacking. We're getting ready to make the decision of whether to attack or move. And so kind of like first thing we do here is decide what we're going to do. Are we going to move, or further down here for our player, are we going to attack? So before we do any of them, we want to make that decision. Well, I guess the first thing we should do is, if we go in here, we should reset our frame counter. That way it's always nice to handle those values first, because they're trivial, which makes them really easy to forget when we think about the harder things. So first thing is, maybe we'll do direction first. We need to pick a direction. I'll just pick a random one. I'll build stuff up instead of just kind of going through everything. First thing we do is pick a direction to move in. So a direction is a vector. I want that to apply a lot. So if we declared it here, it would have local scope. But then the next time we come back around and this method gets called, we get to the end, it'll be deleted and come back around and make a new one. But we want to keep that same direction around. So I'm going to come up here and make a private vector2 to hold our direction. Which direction are we going to go in? And that's why I set this to a really high number. So the very first thing it does is, well, we're past our condition. So the very first thing we're going to do is reset the direction. And well, it's going to be a new vector2, because again, this condition, like, okay, time to pick another direction, or time to decide what to do. That's like our timer. If we're going to, so we might want to pick a direction, and probably a random direction, right? So I want to make sure and include random stuff somewhere. So there's a number of ways to do it. We have one built into Unity. It's in part of the Unity engine, not C# stuff. We have this random range. So we can pick a number between two values. And if we compare that to what we did, but when we pick a direction, we're either hitting our horizontal or vertical axis, which is a number between -1 and +1. So we can just have the computer do that at random. So a number somewhere between -1.0 as a floating point number and +1.0 as a floating point number. Video games usually grow quite large quite quickly. So we want to save those 32 bits from using between a single precision and double precision floating point numbers. So typically everything here is set up in our game engines is set up as floating point numbers. The slightly smaller size, we only have 32 bits for our decimal instead of 64. So it's usually plenty accurate enough to keep track of the pixels on the screen, and saves us a whole lot of space. And what do we do in our script? Once we had that number, then our actual vector that we set up, we took that number and multiplied it by speed. So we're going to do the same thing here. We'll pick a random number and then multiply that by our speed variable, which is we made public so that we can adjust that while the game's running and figure out what a good speed is. So there are a few things, right? We want it to be fast enough to catch our character, but we probably don't want it to be faster than our character so that the player can't get away. So we'll have to hone in on a good speed for that once we see the things interacting on the screen. So that's why that one was made very public. And we can do the same thing for our Y value here. That'll be a good start. This is, if it doesn't see the character, just move in a random direction. And we will see the character, what to do when we see the character here very shortly. So random.range, capital R's everywhere, some number between -1 1 and positive 1. So just a scalar multiple of the speed value we set for both our X and our Y. Then we can just set that for the velocity component. You might have noticed I was scrolling for a minute because all that other stuff we had, which way are we facing, and turn the image around, that needs to happen first. So that's going to happen here in between those here in a minute. But it's programming. The standard rule for programming is run a check every chance we get. So we don't want to write all that code. We're going to take it just one little piece at a time. So first thing is make it move. And then if it looks, once it's moving correctly, then we'll flip our animation to match it. And just like we saw with our player, we can just set our velocity to that new direction we found. I guess the difference is I saved it up here because there's going to be more ways to choose a direction. It's not always going to be a random direction. Here in about, I'm expecting about 15 minutes, a little less than 15 minutes. Aside from the random direction, we're also going to be sometimes we want that direction to point straight towards the player so that we can go attack him. But that should make our opponent move in some random direction and switch directions every 2.5 seconds or so. Before we do that, well, after it compiles and before we run it, our speed is still set to 0. We haven't given it a speed yet. So I'm going to go to the green guy first. So the green guy, and on our script, the one we're controlling, oh, here it is. We set our speed to 2.5. So we probably want the opponent moving a little bit slower than us. That way it can catch us, but we can still get away. So on the blue guy, did I attach this script? Oh, there it is. We have this, we'll set our speed to a little bit slower than the character. 1.75. I'm just taking a guess for a starting number. Maybe 2 would have been a good start. That's a lot closer to our character speed, but if we run it, we should see that the computer control character just start moving in a random direction. And after a couple seconds, well, he hit the edge. I guess he got stuck. Oh, just started moving again, but that looked like a long time. I think he kept trying to go downward and got stuck on the edge. Let me run that again and see if something different happens. Okay, that time he goes up. 1,000, 2, 1,000, 3, 1,000, 4, 1,000. That might be too long to wait for it to change, right? And I think he's just getting stuck there. We try like 2, 2, 2. So I'm gonna stop it, try a different number. Uh-oh. That works. We're a whole lot faster than that character though, right? Actually, it looks like about the same there. That speed might work. We'll see how that goes. But you want to do stuff like that. Pick a random starting speed to start with and move your character around, just find a good one. Because a lot of that stuff is unique to the game. After you've made a few games, you'll start to get a feel for good starting points, but it usually still needs some refinement for the particular animation and setting you're in and all of that stuff. Since we're just going over the concepts here, you all can play around with those numbers later when we're not under time constraints of the classroom, and adjust those. So that gets us started moving in a direction. Sometimes it looked like he was walking backwards though, right? And well, we handled that for our controls. If we look at this, horizontal, that's a local variable. Face left, that's global, and the computer controls have a face left variable on their own, so that'll be there. The player object, that's the thing this script is attached to. Transform.local scale, the thing the other script is attached to will also have that. Everything else is a new vector. So turning that around is going to be exactly the same. I'm just going to copy this and make those couple changes. So after we pick a direction, where's my cursor? Oh, all the zoom stuff's in the way. I use the mouse pad, that way I have left and right scrolling as well. So after we pick a direction, just paste all that stuff in there, and we have a couple changes to make. It's horizontal, which that came from our controls, and we don't have controls here. We picked a random number, stored it in direction, and that direction's a vector, so we can still access the X and Y from it, which is what we need. So instead of the horizontal control, we want to see if direction.x is smaller than 0. And we're not facing left. Same thing when we switch it again. If the X from that direction vector is bigger than 0, and we're already facing left, then we need to turn around. Because that's saying go right, and that's saying look left. So I mean, it's time to turn around. And then once we have that decision made, we just need to refer to the appropriate item. And in the prep skip, with the prep script, the one I keep looking at over here on my right, when I was getting ready, I called the rigid body in both of them. So it was even more of an exact copy and paste. But these words seem to make more sense. So now we should turn around, because we already know that worked for our character. So just copied it over. The X direction has a different name because we're not getting it from the input buttons. And our rigid body component has a different name. So just a couple little changes there. But otherwise, we already know that worked because it worked on the green guy. Oh, name player does not exist in the current context. I apparently missed something called player. Oh yeah, over here. So I'm gonna copy this. This would have been a good place for that find and replace thing. Yeah, actually I'm gonna do that. Whoops. Okay, that wasn't the right button. I'm used to doing that at a PC, sorry. Let me open those back up. Control H, nope, that's not it. Control R. No, it's probably up here in the menu. Find and replace. Okay, yeah, so replace all. Is the one I want? Oh, I'm not sure where it's at in this text editor or what the keyboard shortcut is. I'll just copy and paste. That works. In most of our text editors, it's either going to be Control H or Control R. But apparently on my MacBook here, that's hide on both things. So instead of trying to track that down, I'll just do this. And you can just double click on a word, like a variable name, and it'll select just that variable. So it still doesn't necessarily take a long time to copy and paste. Paste. It's a whole lot easier when the computer does all of that immediately. I'll check and see what it is on the MacBook, because it is Control H on the window one, but apparently on the Mac that just hides the text editor. Okay, that error message is referring to something we haven't got to yet. Yeah, it doesn't say what it is, but that error message is referring to, in our script, where's the script? There it is. We have that variable for the layer mask, but nothing's there yet. We haven't created it yet. We will get to it very, very shortly. So now he starts moving. He's looking the correct direction. And he got stuck up at the end. So random numbers might not always be the best way to do that. Oh, well, we can see he turned around. Now he's stuck against our player. Okay, so it looks like he's facing the right way. Some of those movements might be a little funny. Y'all can play around with those numbers. We can see he moves in a random direction and he faces the correct direction. Get away from the, oh. He was facing the correct direction. But the randomness is strange. He's getting stuck on the wall. That's not the interesting part. Y'all can play around with some of these numbers. The speed and the frame, not that frame counter. The frame counter and the condition, like how big it has to get before he changes direction. Little changes, make adjustments and try that. Make sure he's decide when he should face one way or the other. Looked like he was roughly doing that. But random movement isn't the only one we want, right? We probably want something a little more interesting. We want to know if there's something to chase down. And the way I just said that there is kind of in programming terms, right? We want to know if there's something to chase down. So that second part there, that'll fit right in the condition. There's something to chase down. So we can put that into a Boolean. I'll call it tracking. Oh, whoops, a private Boolean called tracking. And we'll set it to false by default. And it kind of needs to be global scope, because it's probably going to take more than one frame to chase down our player. So set that up, and then we can just check that. Am I closing? Curly brace is closing in the wrong spot. Oh, I see why that guy keeps not moving. We stop moving periodically. This should be after this curly brace. Do you all see why it should be after that curly brace? So our if, let me go through that real quick. So I thought I was talking about it, but it closed at the wrong spot. If our frame counter is that size, then we choose which direction to go in and which direction to face. And then this closing curly brace means that choice is done. So no matter what, we have those choices made by the time we get here. So that's why it keeps pausing, I think. It looks like it's getting stuck. There is a gap where it's not resetting like it should. But we set everything up, and then after making the decisions is when we do this. Including the next thing, which is just like we saw on our opponent. We'll set up, we need a raycast to see if our opponent is there. So I'll set up a vector 2 for the direction we're going to check in. So checking in some direction. And we are either facing left or right, correct? So even if we're up above or below, there's the height of the character. So there's a big range where if we just look left or right, it's going to intersect some part of that character's body and see it. So I'm just going to set it up like that. So like vector 2 dot, I'll just set it to right and then check if we're facing the other direction. If facing left, then flip that over. So I just kind of picked a random one to start with, look either left or right. But if we're facing the other direction, we need to check in the other direction. Because that's when we know how to attack something, right? We're moving around kind of randomly looking for our opponent or coins or whatever we're looking for. And in order to detect it, we have to be close enough to it. I'll do this with the game playing. Nothing's going to crash here yet, is it? So I come over here and run the game. So slowly going over some of the thought process involved here. Because a lot of times when we start out, we are just moving in a random direction in the game, right? We're going in some direction. Maybe there's something over here. Is there stuff down here? No. What up here? No. So we're just kind of wandering around almost randomly. And when we see something, we have to be close enough to see it. So that's our two conditions. We have to be close enough to see it and looking at it, right? Because if I'm looking over there somewhere, I'm not going to see what's going on the screen. That's an accentuated example, but when we set up our computer controls, that's going to make a difference, right? The computer should not be able to see the character when he's behind it. So we need to be close enough to see it and looking in the right direction. So that's what our raycast needs to cover here. What do I call it? And the example I call it spot. So like raycast hit 2D. So same type of data we saw the other day. Determine if we're going to look out in some direction, either to the right or the left, depending on which way we're facing, and determine if we spot anything. So we're not attacking yet. Before we attack, we have to move towards it. Attack will be an exact copy. When we're close enough, we could just copy that raycast over. But this is just looking to see if we need to go in a specific direction instead of the random direction. So we're going to look around and see if we spot anything, which once again is going to be assigned a physics 2D.raycast object. and then all those parameters we needed for ArrayCast. I mean, did I do anything fancy here? 2 meters is what I put. We'll see what that looks like here. Kind of adjust numbers. But first thing is our starting point. So where are we starting at? Well, we're starting at our current thing. That opponent game object. It's a game object, so it has some transform data. And the pictures are in the way again. So a game object, our current one, has some transform data. And one of the things in that transform is the position, which is a vector. Our position does need to be a 3-dimensional vector, or 2-dimensional vector. We'll get to 3-dimensional stuff shortly. It's already 3 o'clock. I was hoping to get to it today. We might not get to it on Monday. We'll at least take a quick preview of it. So alternatively, we have like the X and the Y coordinates since we're in a 2-dimensional vector, but we want the whole vector. Where are we starting at? Then where are we looking? And that's this thing up here that I call checking. So we have this 2-dimensional vector that's either to the left or to the right, the appropriate one for the direction we're facing. Oops, I forgot to turn my phone down. And that is going to have like 5 more alarms from what that is right now. Sorry. So where are we starting? Which direction are we looking at? And how far away do we want to look? In the example I prepared, I put 2. I put in 2, and it seemed to be okay. I moved on from that. But again, it'll take some refinement to figure out what seems like an appropriate distance for the opponent or the computer to spot our character and move up and start moving in our direction. And then where are we looking at is, once again, if we send out ArrayCast, we built up a whole little simulated world. Our game space is full of stuff. The background is everywhere in our game space. So at the very least, we're going to detect that background. So we need to narrow it down by those layer masks. We're going to look and see if there's anything on the green mask, which we haven't assigned yet. So to tell that, remember, we go to the green guy. Over in the inspector, there's a bunch of things called layers. If we start scrolling through here, we'll see sorting layers. Are there any other layers showing up already? I don't see any tiling layers. We see sorting layers at least, and we see layer up here. And notice I looked through these down here. There are other things called layers. They'll show up in our components. But up at the top in the inspector above all of our components, that's just part of this game object itself, there's something called layer. And this is the categories of where the category type layers. So we need to create a new one because there's not one to hold our player object. So I'll add a layer and call it green guys. And then on our green guy, we will assign him to that layer. So that's the layer we want to look at from the script in our blue guy. Which now that it's there, if we go to the script, it was a public variable. That way we could access it from over here. And layer mask, you usually want to leave public because when you do that over in the user interface, you get a drop-down menu of all the layers that are available. So we want to look at this layer and see if we see anything. So from wherever we're at, off in the direction we're facing, some distance, is there anything that belongs to that layer? Is what the ArrayCast is checking here. And if there is, we made a raycast hit object, not just a simple raycast. We only want to know if that raycast hits something, so we can get information about what it hit, and we can just check it. So if spot, it will be null. If it doesn't hit anything, it returns null, which will count as false as far as an if else structure. So if there is something, if it hits something, well, we want to make that our destination. I'm going to call it target, which is probably not going to like this. Spot.collider.game object. So that raycast has lots of parts to it. One of those being the collider. We got information that it intersected something, it collided with something. And we want the overall, the game object it collided with. And I'm gonna put that someplace called target. And now that we have our target, we can set that tracking variable, that Boolean. Are we tracking something? Did we see something? Are we chasing it down? We'll set that to true, and then that will control our direction a lot better than a random number. I have to go up to the top to create the target variable, but does that make sense? Does anybody have any questions about that? Looking off in some direction, seeing that. Okay, if there's no questions, you'll remember about where it is in the video to refer to it. And as always, I'm trying to talk slowly and clearly so that when you pull up the recordings, you can watch those at double speed without any trouble and get through this stuff quicker, having heard the explanation before. So we need a place to store that tracking data, the thing we want to chase down. And once again, we're going to be chasing it for more than one frame of the game. So we want to make sure that has global scope. Private game object, because we have no idea what it is. It could be anything in our game when we're on the scripting side, and we're going to call it target. And we'll fill it in when we get up there. So now that gives us something different to check with our numbers. So instead of just setting our direction here, we want to set our direction a little more carefully. And in the typical fashion for programming, we want our one or the other way to set our direction. If we spot something, we have this Boolean, oh, we're tracking down our player. So we can check that. I'll just do if not tracking. So if we haven't seen anything, then we want a random direction. And remember when programming, the home and end keys are very useful. Like if we hit home and then hold shift and hit end, automatically highlights that whole line of code. So then just copy. So the regular Control-C copy and paste that up there. So if we're not tracking anything, just move in a random direction. But if we are tracking something, we want our direction to be a little bit different. Direction is, we'll set it up as a new vector again, a new vector 2. Only this time, we need to know how far away the thing we're tracking is. I'm going to split this up in a couple pieces. I'm going to make a new vector 2 just to organize this. I'll call it dir. So half of our direction And that'll be a new vector. I don't even have to say new vector 2, do I? So I want to know how far away that other object is. A change, right? A regular math situation of something changing. There's always going to be our old value, set that backwards, our new value minus the old value. Like in time, change in time, or usually notated mathematically as delta time, is going to be our new time minus our old time, or our end minus our start. Because we want the start and end of this ray vector, a ray cast down there to see how far we went. So the end is the player that we spotted. So that is going to be our target, that game object we grabbed. It has some transform data because it is a game object. And some of that is a position vector. And from that, we can subtract our own position vector, component.transform.position. And that gives us the vector we want to go in. There's a slight change we need to make still before we go and apply that to our direction. I don't know why I copied that. I should just cut that one out of there. That's already moved up there. So that gives us the vector we want to go in, except for one slight issue. If we're all the way across the screen or the full distance away, that's going to be it's going to give us that number. And if we're really, really close to it, it's going to give us a really small vector. But we want to move at our speed. And when we did our normal direction, we took something between 0 and 1, both positive and negative directions, but a 0 to 1 value, and that was our direction that we multiplied by speed. So we want to do the same thing here. We don't want this full vector. We want the unit vector in that direction. Anybody heard that word before? Or have any guesses on what unit vector means? Think about the word units. If we're measuring something in meters, meters are our units. So our basic measurement would be 1 meter. If we're measuring something in pounds, the weight of something, pounds are our units. So our basic measurement is 1 unit, 1 pound. So we want to turn, same thing with vectors. We don't want the full vector. We just want 1 unit in that direction. And the term for that is normalize. We want to normalize this vector. So whenever we have a vector in Unity, either 2D or 3D, we can throw in the dot operator at the end. So I wrap that difference in parentheses, then subtract that, and that difference is 1 vector, but we want to normalize it, and it's stored in a variable called normalized about that vector. So we find the vector we want to go in, and then we normalized it for the one we want. Which again is going to probably sounds like big fancy words because you're here at the introduction level and you may not have seen the word normalized show up in a math class. The length of a vector is called its norm. The norm of a vector is how long it is. So when we do that subtraction, what we have is the norm of that vector between the two. But we don't want the whole distance because we already know how fast we want to go. We just want to know the direction. So we have to take that norm and normalize it so that it's just a unit vector. It's only 1 unit in that direction. And then that's what we'll set to our overriding direction vector that we're going to move in. So our direction is going to be a new vector 2 that we have to build up from our components this way. So we have this dir vector, like half of what we want, half of the direction we want. It's just at the wrong, it has the wrong length to it. Or it might have the right length. We don't know. It might not have the right length though. So that normalized turns it into a length of 1 or something. A length of 1. So then we can multiply that by our speed. So whatever the x value is of that, we'll multiply by our speed to get the x component. And whatever the y value is, we'll multiply by our speed to get the y component of that vector. I'm gonna take a second so that all that sinks in. Does anybody have any questions about that? Just based off the prereqs, I have a feeling that is from a much higher math class than anybody in here has seen. Right? It's the introduction level. Some of this is probably overwhelming. And it makes it seem extra hard, right? Once you start to learn what these things mean, this is a whole lot easier. Because this is just the standard. The prereqs for this class were Math 023, just the one math class. That's all you need to get into the SDEV 120 class. And that is the most fundamental level of algebra. Like the most complicated thing in that, I think, are lines. Y equals mx plus b. You might not even get up to it in the generic form. You might be looking at y's and x's and you'll always see it with numbers. But this is, once you've seen this stuff in a math class, it should make perfect sense and not, but at this point, you probably haven't seen it in math class, so it looks like a bunch of big words coming out of nowhere that look extra confusing. But yeah, as you progress through, get more experience and further along in your education, you will see a lot of these things and then it'll make sense what's going on with them. Trying to explain it some, but it's different when we see it in a math class, right? When we do a whole section, homework section of a whole section's worth of homework in a math class, and then turn around and apply it to a program we're writing is very different than when we just see those words. Oh, what error message did I get? On line 61, did I spell that wrong? I should have cleared those before running it. I think I fixed it, but it didn't clear the messages out. I should have hit that. Remember to hit the clear button before you try to fix things. Oh, that looked pretty good. He ran right over to our character. Now I guess I should try to get away from him. It looks like I can outrun him. But it's not random directions anymore. And that logic, it will apply the same way. What is this referring to? Null reference exception. It doesn't seem to be causing problems. I've made it a point not to go into the Unity source code in the class. That way mine's doing the same thing as yours. So I haven't changed anything, even though I really, really wanted to before going into the 3D stuff, because it makes something so much easier. And it's like, I probably shouldn't show them how to change the source code of Unity at the intro to game development course. That's for later. So I've been trying not to do that, but that looked like it was referring to source code, not my stuff. I didn't have any files with those names or folders. But it doesn't seem to be causing any problems. I guess the last step here is want to go ahead and attack, but that's going to be pretty much exactly the same thing that we did when our player attacked, right? We'll set up a raycast 2D object called slap. It's a new physics 2D raycast. Go ahead and put that semicolon at the end so I don't forget that after all the hard thinking parts. And what do we need? So once again, a raycast we have a starting point and a direction to look in. So what do I do here? Did I use the same one? I used the same one I did earlier, and that worked fine for when I was preparing. So our starting point is our opponent, the thing we're currently coding, has some transform data, which includes its position. So we're going to start there. And well, we can look in the same direction we looked in order to know if we needed to chase something. But we don't need to look as far. Here we were looking 2 units away, whatever our units are. But we already saw when we adjusted our character, 0.2 seemed like a good distance to slap the other character from. So our distance, we're looking in the same direction, just not as far. And once again, we want to slap the player, which is identified by the green layer mask category. What is that? 4th time we've seen an array cast. So hopefully that was making a little more sense what to do. And then more, as opposed to just copying that from a tutorial example, hopefully you're getting an idea of what a raycast is, so that when it goes wrong, you can go in there and debug and mess around with that stuff and debug it. The starting point, the direction, the distance, and then what category do we want to look towards? Yeah, I'll write this whole thing out. So when we did it, well, when we saw something, I'm just going to put it on the debug.log. Blue got a hit. Probably want to do something more interesting than that. We'll adjust our animation. Animator dot set bool. Remember earlier we were just looking at it, so we just check to see if it was true or false. Here we want to set it to true. We put up that attack boolean in the animator, and when that is true, we'll switch to the slapping animation. And then I kind of want to reset. Right? After we slap the character, we want to jump all the way past this stuff. Right? We want to go ahead and pick a new direction, forget that we're tracking the thing and everything. So once this happens, we'll set tracking equal to false, and then set our frame counter to something, I don't know, maybe 210. Something just below our reset value. It's going to cover 12 frames pretty quick, right? It's 140 frames a second, so it'll cover those last 12 frames in less than 1/10 of a second. But we don't want that to happen instantly. to kind of smooth out the change, just do it for a few frames before. That's just something I found over the years, kind of works out nice, makes the transitions nicer. Don't jump right to the end. Like I used to do something like 400. I'd go way past it, and then that transition was very sharp. So just backing it off a little, even a fraction of a second, helps to smooth the transition between that attacking state and back to the random direction state. Anything else I said there? But that should be fine. One last change that relates to that. And then when this resets, so 12 frames later, then we will change our animation back. Animation.set bool. We'll set that attack boolean to be false so that it stops slapping. Maybe that's another way to describe that transition, that slow bit. It's not one frame of a slap. That's way too quick. It'd be hard to notice. So it stretches it out over a couple frames so we can clearly see it. One last piece here though. When we slapped the thing, we wanted to make sure that it was after we pressed that button. So we need something to make sure this happens. And this relates back to that point I made earlier. You want to be on the player's side, right? We're not writing this game to challenge somebody, right? It's not programmer versus player. It needs to be game versus player. And right now, the computer is going to be very, very accurate on that. As soon as it's there, it's going to be too quick to handle human reaction. So we'll need an and condition like we had, but here we want to back that off and use some sort of probabilities on it. What I did in the random example, which is a good start for these sort of things, just backing it off a little, is I'm going to take a random range like a probability. So 0.0 and 1.0. So something between 0 and 100%. 0% is 0.00 and 100% is 1.00. So a probability, a chance of something happening. Oh, my other computer went to sleep. Let's say 1 in 5. If this random probability is less than 20%, that means there's a 1 in 5 chance that the computer's going to slap us. Maybe that would be good for the game. Maybe we need to increase that, adjust it. Again, another number to just kind of mess around with. Kind of like rolling the dice. A lot of people that get into game development have played a number of rounds of D&D. So setting that up like a 20-sided dice. So instead of floating point numbers, we use integers, going from 0 to 20. And if it's equal to 14, kind of equivalent to a D&D sort of roll. But some sort of way to back that off from guaranteed to happen every time the instant the computer detects it. Because that will just, the player doesn't stand a chance on those. Oh, whoops. It's a raycast hit. Raycast hit 2D, not raycast data type. Raycast is a category of data types. We just want one of the items out of that category. And then, yeah, that's referring to something in Unity. I'm not sure what that error message is. My computer, when I shut down Unity, it will automatically report that error message back to them. I think I have that turned on. But when we run this, now we should have something. Obviously, there's so much more we could do, but it's going to start to seem more like a full game. There we go. It is 63 times. He comes back over. Keeps hitting us. But we're faster, so we can get away from it and avoid getting hit. Or he'll track us down and hit us again. I guess the last thing to make it more game-like is there should probably be more than one opponent, which we can just do this. Come over to the hierarchy and select it. The regular Control C or Command C if you're on a Mac, then Control V to paste it. Let's just put a few of them in there. And up here we can change our controls. So I'll just paste in a few of them, go to the move control, and move them to random spots around our world. Right way over here. Still a couple things that should be fairly, you should have enough knowledge to fix a couple of things. Like one, when I run this here in a second, you probably already realized that if I knock that guy down, he's going to keep moving, right? By the code, there's no restriction that he has to be standing upright to move. But that should be an easy fix. We have access to the game object, so that'd be one thing to try. Hone in on some numbers, find a good probability value for when to attack and when not to attack. So if I come down here and get him first, you can see he still moves. But you should have know enough to kind of fix that. Oh, this one's not falling down. Uh-oh. And I'm pinned in. So it might be better to go back to the destroy instead of just knocking them down. So I'll do that, but I'll leave it commented out. So I'm going to do this just for now. But one of my recommendations for messing around with stuff and kind of getting used to this, all of this logic applies to 3D as well. We kind of ran out of time to do that today, I think. But we just have one more number to put into our vectors, and they're all called vector 3s instead of vector 2s. The way we set up animations is the only thing that's different. We have raycast hits instead of raycast 3Ds. And other than the vectors say vector 3, because we can have many dimensions in a vector. But most of our stuff like rigid body 2D, the 3D version is rigid body. Still behaves the same. Instead of raycast hit 2D, we have raycast hit for the 3D version. So I'm just going to destroy it so it doesn't keep moving. But one of the things I would recommend playing around with to make sure you understand what's going on and these different pieces is uncomment that line and see if you can get them to not keep moving and trying to attack once they've been knocked down. Destroy works too, though. So I'm going to wait for him to come hit me. Yeah. And then I'll start doing stuff. That way they don't get in the way. But a little more game-like, right? When they're not moving around randomly. It's actually chasing and attacking me. And there seems to be some sort of bug there. If both of us are slapping at the same time, I can't seem to slap him. I don't know if that's a bug or not. It almost seems like something that should be there, right? We can't hit each other at the same time. And it does look like they're hitting awful quick. So maybe lower those probabilities might be a good idea. Does anybody have any questions about that stuff? Hopefully all those concepts are making sense. Because yeah, it's already 3:30. That went longer than I thought. So I guess we'll do the 3D stuff on Monday. I will send these files out here in a minute because this is an active subject. We want to make sure there's plenty of time to do stuff and apply these concepts. Try to make sure you're understanding what's going on, make changes, and hopefully it's all understanding and it's not just arbitrarily copying the syntax so that you can do this on your own. Working some small improvements there. Like before, there's still that discussion board on Ivy Learn, where if you want to, you can, if you mess around with that and make some adjustments, make sure you understand it. If you make something you like, you want to share with your classmates, that other discussion board is still there. I'll comment on that one. The other discussion, the regular discussion boards are for you all, but that one where you're like sharing work you're proud of, I'll throw some I'll comment on that one as well. And then Monday we'll do this. Ran out of time. So this is our the quick pass at the 3D one. Well, let me restart that because my mouse needs to be in a particular spot when I start it. Otherwise, the camera's at a weird angle. So I just picked some arbitrary animations. You can see the normal, what should seem like normal controls, right? For the camera, going in and out, back and forth. Switch over to this animation, walk around up the hills and stuff. Adjust our camera so we can see what's going on in different spots. Oh, looks like a desert, nice little ledge to hide under. I did that desert scene in 45 seconds. I was actually really, really happy with how good that came out for 45 seconds. I was like, wow, that was supposed to be an arbitrary one, but I'm gonna have to save that. That needs to be moved out of my delete folder for just a couple seconds. But that is what we'll do on Monday, coming up soon. And logically, the way a lot of that stuff happens is what we just saw in 2D. So all we need to do is add that z-axis in. We already saw what to do on the x and the y and how to interact with other things. The only difference is we need a third number added in, and we have to make our animations differently, which is we have to make those elsewhere, which we'll make in Blender and then send in there. Otherwise, does anybody have any questions about the stuff from today? I want to make sure there's plenty of time to mess around with these things.
I think I'm good.
Okay, if you have any questions, let me know. I'm always happy to help. I want to make sure there's plenty of time. That leaves us an hour and 10 minutes to mess around with things. As normal, I'll be sitting here. Text messages and Ivy Learn messages make noise on my phone, and until 4:50, I can jump back on the call in a split-second time. But you can ask me questions anytime. Mess around with those concepts, because hopefully that makes sense. That to switch that, what we just did from 2D to 3D, all we need to do is throw in the Z numbers. It's logically, it's almost identical. Same words and stuff. Similar words, we'll drop the twos. But otherwise, I will see you all on Monday. Everybody have a great weekend. And then we'll get into the 3D stuff.
All right,
Have a good
Good
weekend.
one, Chris.